Morning. Sorry for the little delay. So you are not celebrating festival. This many students are attending the class. Good. Okay, so wave optics. I will start from the beginning. Okay, from the or only the YDSC is the problem. So it is better that I have to start from the beginning. YDSC means Huygens principle. Then I will go to the interference. Then I will come to the YDSC. Okay. If required, then another class also I will take later. Okay. So first thing, what was the Huygens principle? Okay. Because sometime maybe theoretical question if they are asking who gave the secondary wavelet theory, or Huygens gave which theory like this, which experiment verify the wave nature of light, which experiment verify the particle nature of light. So we have learned light has the dual character. Which experiment verifies the particle nature? Photoelectric effect. Another effect is also there, Crompton effect, but Crompton effect is not in our syllabus. So two experiments verify the particle nature of light. One is photoelectric effect, other is Crompton effect. Okay. Rest whatever we have learned in the light, reflection, refraction, diffraction, interference, polarization, all are wave nature. All are wave nature. Okay. This everybody got. So what Huygens gave? Huygens gave the secondary wavelet theory. Huygens gave the secondary wavelet theory. What was the secondary wavelet theory? So when wave propagate in the medium, then all medium particle behave like a source. All medium particle behave like a source. Then they will emit the wave. That wave is called the secondary wave or secondary wavelet. Okay, that's why this is called the secondary wavelet theory. So when wave propagate in the medium, then all medium particle behave like a source and they will emit the secondary wave. That was the secondary wavelet theory. Okay. By using his principle, by using his theory, he explained the reflection, refraction, all except polarization he has not proved. But polarization is also the wave nature. In the module also question has given which phenomena Huygens has not explained by his wavelet theory. So it is a polarization. Okay. Up to this everybody got. So in a wave, one example I am taking from the beginning. Suppose you are standing in the, that is the best example what you have seen in the like in your normal life or daily life. When you are standing in the mess queue and then last student, suppose there is 100 students are in the queue. Okay. Now students start laughing. They remember that example. So suppose 100 students are in the queue. Last student push the first next student. Then what will happen? Suppose last student push, then 99th got the push. Now what the 99th will do? It will transfer the push to the 98. 98 what it will do? It will transfer the push to the 97. Like this way, wave will transmit from the 100th student to the up to the front of the row. So then what will happen? Here disturbance transfer without the transfer of the medium. No any student get displaced from their place. Only they transport the disturbance. Okay, that is the best example of the wave. In that, who is getting the wave? They are becoming the source and they are transferring the jerk to the or push to the next. So like that, first who was the source? 100th student. Okay, he transferred the wave to the 99th. Now 99 become the source. It transferred the wave to the 98, then 97, 96. Like that, wave transfer from one place to the another place. Like all medium students are behave like a source. Everybody got or not? That was the secondary wavelet theory. Okay. And in that, he introduced the concept of the wavefront. So what is a wavefront? So you marked up the definition. Wavefront is the locus of the point. Those have the same phase of oscillation. Wavefront is the locus of the point, those have same phase of oscillation. Means all particle who will be in the same phase, when we will join them, what is the shape we are getting, that we will say as a wavefront. That is the meaning of locus. So when we are joining all the points, those have the same phase of oscillation, then that path or that locus is called wavefront. Like I will take the example. Suppose I have the point source, okay? At t is equal to 0, I switch on the source. At t is equal to 0, okay? You switch on the source, that is a point source, suppose I am taking, okay? We marked the point source shape of the wavefront is spherical, okay? I am showing how it will be spherical. Source you switch on at t is equal to 0, okay? Now when you will switch on the source, it will start emitting the wave, okay? Suppose wave velocity I am taking v. Okay. Now at t is equal to 0, when I switch on the source, the source start emitting the wave, okay? Now wave is traveling with speed v. So in time t, how much distance the wave will travel? Vt. In time t, how much distance the wave will travel? Vt. So it will travel Vt distance here, it will travel the Vt distance here, it will travel the Vt distance, means all the direction wave will propagate. Vt. Everybody getting or not? Now the particles who is located here. Suppose I am taking here A, here B, here C, here D. So many particles will be there at a distance Vt from the source. So A, B, C, D, I have shown only 4 particles. They will get the wave after what time? When I switch on the source at t is equal to 0 and wave is traveling with the velocity Vt. So they will get the wave after what time? Vt. They will get the wave after the time t. They will get the wave after time t. Why? Wave will travel how much distance here? Vt. So how much time it will take? T. So A will get the wave after time t. B will get the wave after time t. C will get the wave after time t. It means all these particles, when they will get the wave, they will start oscillating. When they will get the wave, they will start oscillating. So A, B, C, D, like that particle who is at a distance Vt, they will start oscillating when they will get the wave. And when they are getting the wave, they are getting the wave after time t. So now all these particles, they start oscillating together simultaneously. It means they will be in the same phase. They will be in the same phase. When I will join them, what I will get? I will get a sphere. That's why we are saying point source shape of the wavefront is spherical. For the point source shape of the wavefront is spherical. Why? All the points which is at the distance Vt from the source, they will start oscillating simultaneously. Okay, means all will be in the same phase of oscillation. And locus of the point who has the same phase of, those are the same phase of oscillation are called wavefront. Okay, so what is the shape of the wavefront? Spherical. Okay, so for the point source, we got the shape of the wavefront spherical. That is the one thing. So this is the direction of propagation of wave. Wave is traveling in this direction. Here wave is traveling in this direction. Here wave is traveling in this direction. Wave is traveling in this direction. Now you can see all direction of the propagation of wave we can represent like a radius. These are the radius, na? Here this is the radius. Here this is the radius. Here this is the radius. And we know that radius is perpendicular to sphere. Radius is perpendicular to the circle or sphere. It means second point what we have to remember, direction of propagation of wave or wave we can say. Direction of propagation of wave or wave and wavefront, they will be always perpendicular to each other. They will be always perpendicular to each other. Why? This is the wave direction, this is the wavefront. If you draw the angle here, tangent here, what is the angle? 90. Here also 90. It means direction of propagation of wave and wavefront, they will be always perpendicular to each other. This is the next point that you have to remember. Everybody got or not? Okay. Now, how we will get the next wave? Now, A, B, C, D, they will behave like a source. That was the second point. Maybe they can say which point is the true about the Huygens principle, which point is the false about the Huygens principle. Okay. So next point that is given in the NCERT also. A, B, C, D. Suppose they got the wave. Now they start oscillating together. Okay. A will emit, now A become the source according to the secondary wavelet theory. B become the source, C become the source, D become the source. Now they are emitting the wave. They are the point. So what is the shape of the wavefront? Spherical. Okay. So again now A will emit the wave. And what is the wavefront? Spherical. So suppose A emitted the wave in the time t dash. In the time t dash, how much distance the wave will travel? Vt dash. Here it also emit the wave. What is the radius you will take? Vt dash. Similarly like this all. Okay. What the Huygens assume? When secondary source you are considering. So in normal life also, suppose any source is giving the energy. You receive the energy. We are giving the energy, like bulb is glowing. Bulb is getting the energy back. No. Energy we are taking, it is a propagating in the forward direction. So what the Huygens in the principle, what he has assumed, amplitude of the secondary wave. Amplitude of the secondary wave is maximum in forward direction. Amplitude of secondary wave is maximum in forward direction, and reverse direction it is 0. Reverse direction it is 0. What I said again, I'm repeating. Amplitude of the secondary wave. Amplitude of the secondary wave means like these waves. Amplitude of the secondary wave is maximum in forward direction, and reverse direction it is 0. It means all energy is going in the forward direction. Energy is not going back to the source. So we will not consider complete sphere. We will consider what? Like this. Here also like this. Means energy will only propagate in the forward direction. When you will join them again, you will get the next wavefront, and whose radius will be V into T plus T dash. Everybody got or not? So what we have learned up to now? Wavefront is what? Wavefront is the locus of the point. Those have the same phase of oscillation. Those are in the same phase of oscillation. Second thing, wavefront and the propagation of the wave, both will be perpendicular to each other always. Okay. Third thing, what I said, in forward direction, in the secondary wave, forward direction amplitude is maximum and reverse direction amplitude is 0. Up to this, any doubt anybody has? Fourth thing, what you have to remember for the wavefront, distance between consecutive wavefront is the lambda, because source is emitting the wave. One wave means one wavelength. One wave means one wavelength. So what is the distance between consecutive wavefront? That will be equal to lambda. Everybody got? Up to this, any problem? Okay. So two, three wavefront shape you have, you remember, or maybe sir said. One is what? For the point source, shape of the wavefront is spherical. Okay. Second, line source. Line source, when we are considering like this, then it is emitting the wave VT, 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 like this. In this direction also VT, VT. So when we will join all, what I will get? Here if I'm joining, here if I'm joining. So what is the shape I will get? Cylindrical. So shape of the wavefront for the line source is what? Cylindrical. This everybody got. So point source is spherical, line source cylindrical. But in general, always we will consider the point source only. Everybody got? In NCERT, one line has given. Why, and from that you can get why we are, when the object is, when the source is far, or when we are putting the object at infinity, why we are considering the parallel beam of light. By wavefront, we can explain this also. When the object is at infinity, why we are considering the parallel beam of light? So suppose I'm considering the earth, this is the earth, and there is a sun. Okay, sun is giving the light. Who is the source of the light? Sun is the source of the light. Now from the sun, light is falling on the earth and it is coming. Okay, so one line they ask, what is the shape of the wavefront? What is the shape of the wavefront when we are considering a small portion of the earth? A small portion of the earth, what is the shape of the wavefront? Anybody will say, what is the shape of the wavefront when we are considering a small portion on the earth? Shape of the wavefront when we are considering a small portion on the earth. Shape of the wavefront, when planar. Shape of the wavefront, that is a planar. Okay. Now listen, why? Because suppose you are considering because on earth we cannot see. So suppose you are considering big watermelon. Okay. From the big watermelon, you are cutting the small piece of the watermelon. Okay. So when you are cutting the small piece, then you can see from the front it will appear as a straight line. But when you will consider in the 3 dimension, it will appear as a planar. It will appear as a planar. So sun is very far from the earth. Okay. Now from the sun, light ray is falling on the earth. When we are considering very small portion, earth is a very large. When we are considering very small portion of the very big sphere, so it will appear as a planar. It will appear as a planar. So that's why small portion of the earth, when we are considering and the light is coming from the sun, so we can say the shape of the wavefront is planar. Shape of the wavefront is planar. Okay. Now suppose I am saying wavefront is planar. This plane I am considering. So one thing we know that plane for the planar wavefront, then where is a wave? We know that wave and wavefront are perpendicular to each other. Wave and wavefront are perpendicular to each other. So suppose I am considering the planar wavefront. Then what will be the wave? Wave will be like this. Why? Wavefront is planar. So then wave will be perpendicular to the wavefront. So all the wave will be parallel to each other. That's why when we are taking the object at infinity, we are considering the parallel beam of light. Everybody got or not? So for the far source, we can say shape of the wavefront will be planar and nature of the light ray will be what? Parallel. Everybody got? In whole ray optics, we never deal with the wavefront. So we are more comfortable in the ray. We are not comfortable in the wavefront. Wavefront only we are learning in this chapter only. Okay. So when they are asking what is the shape of the wavefront, reflected wavefront, refracted wavefront, then what we will do? We will go to the ray first. After getting the ray, then we will decide the wavefront. Again, I am repeating. Suppose they are saying this wavefront incident on this surface or mirror. What is the shape of the refracted wavefront? What is the shape of the reflected wavefront? Then what I said, we are comfortable in ray. So first we will decide the ray. After deciding the ray, then perpendicular to the ray, wavefront will be there. Everybody got my point? I will show some example. Okay, so 3 things everybody got. Point source, shape of the wavefront is spherical. Line source cylindrical, and planar means source is at infinity, means parallel beam of light, or far source, then the shape of the wavefront we will take planar. Okay. So in NCERT 3 question they have given. Suppose this is a convex lens. Okay. I am saying a planar wavefront incident on the convex lens. Planar wavefront incident on the convex lens. What is the shape of the refracted? Because from the lens refraction will take place. What is the shape of the refracted wavefront? What is the shape of the refracted wavefront? Now, maybe directly from the wavefront, we cannot decide. So what I said, we are comfortable in the ray, we will take the ray. When wavefront are planar, then what is the nature of the light ray? Nature of the light ray will be parallel. So like this. When wavefront are planar, so light ray will be parallel. Now we know that in the ray optics, when parallel beam of light fall on the convex lens, then it will converge at focus. It will converge at focus. Okay. So here wavefront is given planar, so I go to the first ray. Ray is parallel. Ray is parallel. So where it will converge? It will converge at focus. Now like this. Okay, this is the refracted ray. Now we know that ray and the wavefront will be perpendicular to each other. Okay, now all are meeting at a one point. That point is the focus. All are meeting at one point. That is what? Focus. Now when one point you have, all are meeting, means reverse you can think. If you think reverse, suppose this is the point and ray is diverging from this. All the ray are going back like this, diverging. So for the point source, what is the shape of the wavefront? Spherical. For the point source, shape of the wavefront is what? Spherical. Here what is happening? All the rays are meeting at a point. Earlier what I said, all the ray was going from the point. So ultimately for the point, what is the shape of the wavefront? Spherical. Then in that case, what is the shape of the wavefront? This is the point, like light rays are diverging. So here, so big sphere, then it is a shape, size is decreasing, and then it converges at the focus. So what is the shape of the refracted wavefront? Converging sphere. Why? The big sphere you got here, big sphere. Okay, then size is decreasing, and then it converges at the point. So in that case, what I can say, shape will be refracted wavefront will be what? Converging sphere. Are everybody got or not? From here also we can say it will be what? Converging sphere. So when planar wavefront incident on the convex lens, what is the shape of the refracted? Refracted wavefront? Converging sphere. Okay. Are everybody got? Sir, voice is okay. Is this revision class, sir? Syllabus not completed, how revision will start? Nalayak. It is just because some student has the problem, so just I took because I have not taught this topic, in between I was not there. First wavefront, that is a consecutive wavefront, we will always take the distance is the lambda. Okay. Now in the place of the convex lens, suppose I gave the concave lens and planar wavefront incident. First you will say, if the planar wavefront incident on concave lens, what is the shape of the refracted wavefront? Tell fast. What is the shape of the refracted wavefront? Diverging sphere or converging sphere. Diverging sphere. Why? We know that in a case of concave lens, a parallel beam of light fall on that. So nature of this lens is diverging. So it will diverge the ray like this. And it will appear to diverge from the focus. Okay. Now if I'm saying what is the shape of the refracted wavefront? Now here it is a diverging from the point. So what is the shape? Diverging sphere. EM wave also teach, sir. Okay. So you are at home for the holidays or for the classes? Okay. Everybody got? So in that case, what is the shape? Because the light rays are diverging. So we can say, and from the point. So what is the shape of the wavefront for the point? Is spherical. And that it is going like diverging. So I can say the shape is diverging sphere. Okay. First thing, what I am teaching, focus on that. Nuclei also and EM wave also, that we will discuss in the revision also. Okay. This completed. Now fast answer, okay? if the planar wavefront incident on the concave mirror, what is the shape of reflected wavefront? Because in the case of the mirror, we will say the reflection. What is the shape of the reflected wavefront? Converging. Good. Okay, so we will take the ray. Again, ray like this. Now parallel beam of light is falling on the concave mirror, then it will converge at focus. Okay, it will converge at focus. So this is the focus. Now here what is happening? All the rays are coming to the point. It means here what is the shape? Converging spheres. We will consider like this. We will consider like this. Everybody got? Last example of the NCERT. In the prism, suppose this is the prism and planar wavefront incident on the prism. Okay, what is the shape of the refracted wavefront? What is the shape of the refracted wavefront? Planar wavefront incident on the prism. What is the shape of the refracted wavefront? Now listen, prism property we have learned what? All prism always it bend the light ray towards its base. It bend the light towards the base. Planar wavefront means you can take the light rays are like this. Okay, so like wavefront continuous wave, only one wavefront is not there. That is the continuous wave is coming. So we can say the ray is like this. Okay, what the prism ray? What I said from the wavefront directly we cannot decide. So we will decide from the ray. Okay, now what will happen? This parallel beam of this light is falling. The property of the prism is what? It bend the light towards the base. So it bend the light towards the base like this. This is going, it will go towards the base. It will go towards the base. Okay. Everybody getting or not? So it will bend towards the base. Now, when wavefront is going inside, you can see bottom wave, that wave will travel more distance in the denser medium. This ray will travel less distance in the denser medium. This ray will travel more like lesser. Means who is near the bottom? Which wavefront portion is the near the bottom? That is traveling maximum distance in the denser medium. And who is the near the top? It is traveling lesser distance in the denser medium. In denser medium, speed of light is c by mu, means light will travel slower. So which part of the wavefront will come first? Which part, suppose this wavefront goes inside the prism, which part will come first? Upper part will come first, then lower. So upper part come first and they are traveling together. So in the same time, who will travel maximum distance? Upper part. So upper part, suppose it reach here. Lower part slightly less. Then this part slightly less. This part slightly less. Like this, when you will join, you will get the tilted plane. Tilted plane. Everybody getting or not? And ray is what? Ray is like this. So ray, from the ray, it is easy to decide. So parallel beam of light fall, then we know that it is a property of the prism, it bend the light towards the base. Now it is going towards the base. Now our wavefront will be perpendicular to that. Perpendicular to that means we can take like this. Everybody got why we got this shape? Because bottom will travel more distance in the denser medium, so it will take more time to come out. If I'm considering the same time when the whole wavefront came out, so in that time, upper one will travel maximum distance, lower one will travel the minimum distance. According to that, wavefront will be tilted. Understood or not? So these 3-4 examples that you have to remember because it is given in the NCERT also. Okay. Completed. Last thing, suppose this is the boundary of the rarer and dense. YDSC I will come like wait. So it is a rarer and denser medium boundary. This wavefront incident, and I have taken the planar wavefront. Okay. Then it is going to the rarer to denser. What will be the shape of the? What will be the refracted wavefront? Okay. So first thing you have to remember what? if I have given the angle plane incident at what angle? This is a wavefront. It incident from the surface, how much angle? Theta I gave. Okay. So suppose I am asking, what is the angle of incidence for the ray you will take? If wavefront incident at an angle theta on the surface, wavefront incident at an angle theta on the surface, at what angle, what is the angle of incidence for the ray you will take? If the wavefront is making angle theta with the surface, what is the angle of incidence you will take? What is the angle of incidence you will take? Theta, 90 minus theta or something like that I am asking. If the wavefront is making an angle theta with the surface boundary, then what is the angle of incidence for the ray you will take? 90 minus theta. It will be theta only. That you have to remember what I said. Whatever the angle wavefront is making, whatever the angle wavefront is making with the plane, wavefront is making with the plane, same angle the normal ray is what? Normal to the wavefront. Okay. Angle of incidence we are measuring from the normal to the surface. Now you can think. This angle I have taken theta. This is the wavefront. This is the plane. Okay. I want to get the angle of incidence. Ray will be perpendicular to the wavefront. This is the ray. Ray will be perpendicular to the wavefront. Angle of incidence we measure from normal. I draw the normal here. Okay. Now you can see theta 90 minus theta. So what is this angle? Theta. Everybody got? So what I said, whatever the angle the wavefront will make with the plane, same angle we will take for the angle of incidence, which ray will make with the normal. Are everybody getting or not? So here what is the angle of incidence we will take? I is equal to what? Theta. Now we know that when the light is going from the rarer to denser, it will bend towards the normal. So when it will bend towards the normal, it will go like this. Angle will be lesser than theta. Okay. Now wavefront you can say like this, perpendicular to the ray. So here it's an incident. Here this angle will be less than. Suppose this is theta dash. So we can say theta dash will be less than theta. Theta dash will be less than theta. Why? In the denser medium angle, light ray will bend towards the normal. So this angle theta dash. This angle theta dash. So this will be also theta dash. So theta dash I can say less than theta. Completed. So this is about the Huygens principle. Now come to the interference. Okay, so what is the interference? So interference generally, when in the normal talk we are saying somebody is interfering in between. Okay, so interference means what? When suppose I am teaching, in between somebody is talking, so they are interfering. Okay, so interference is the meeting or the superposition. Normally we can say when the two or more than two waves are meeting, so then that is called the interference. Okay, but to get the stable interference, because suppose in the interference we have learned YDSC, we have used the white light interference also. Okay, so 7 colors are interfering, that is okay. But to get the stable interference pattern, condition is what? Sources must be coherent. So interference is what? It is a what? Two or more than two waves are meeting. Then we can say it is a superposition of interference. Okay. To get the stable interference, necessary condition is what? Sources or the wave must be coherent. Okay. So what is a coherent wave? So coherent wave is what? So interference is what? It is a superposition or the meeting of the two or more than two waves. Then there will be the distribution of the energy or intensity at the different point. That is called the interference. To get the stable interference pattern, sources must be coherent. Sources must be coherent. Again, I am repeating, for the stable interference pattern, means you can see this is the interference. Here intensity more, here intensity less. If you want to observe that, then for the stable interference, sources must be coherent. Sources must be coherent. Like beats already we completed. In the beats, what was happening? Suppose I am standing here and the two different frequency sound waves are meeting at me. So what was happening in the beats? We were hearing the continuous sound. In between, we were hearing louder, low, louder, low. That was called the beats. Number of maxima or number of minima per second is called beats. In the beats, frequency of the sources was different. Okay, those can never be the coherent. So here what I'm saying, in the interference, suppose I want to observe here maximum, here minimum. So if I want to observe maximum at some point, so always intensity has to be constant there. Then only I can say, okay, here I am getting more bright. Here I am listening more louder sound. Here I am listening low sound. Here I am getting the darkness. So to identify darkness, brightness, and loudness, low sound, means whatever is there, it has to be constant, and for that sources must be coherent. Sources must be coherent. To get the stable interference pattern, sources must be coherent. This everybody got or not? Okay, so necessary condition for the stable interference is what? Sources must be coherent. Okay. Okay, then. Now, suppose I am considering one more thing then. Then what is the coherent sources? What I said, coherent sources must be coherent. So what are the coherent sources? So coherent sources are the sources which has the constant phase difference. Constant phase difference. Maybe phase difference are there, but whatever are there, it has to be constant. Okay. Like I am writing the example, y1 is equal to suppose a1 sine kx minus omega t, and y2 is equal to a2 sine kx minus omega t plus phi. Now by this two wave equation you can see what is the phase difference between them, phi. Suppose phi I gave pi by 6. So I can say their frequencies are same, because if the frequencies will be different, what will happen? Suppose I am taking here omega 1, here I am taking omega 2. So when you will subtract, what will happen? Kx and kx get cancelled out, suppose. Okay. After subtracting, you will get what? Omega 2 minus omega 1 into t plus phi or minus phi, whatever. Now as the time will change, omega 2 minus omega 1 into t will change. It means with that change in the time, phase will also change. So what I will say, these two waves are not coherent. These two waves are not coherent. Why? If I will subtract the phase of this is this, phase of this is this. If I will subtract, then what I will get? Omega 2 minus omega 1 into t plus phi, or omega 1 minus omega 2 into t plus phi. Time is changing, omega 1 minus omega 2 into t will change. It will change, phase will change. So means phase is changing with the time. So the waves will not be coherent. But if I am taking this, then if I will subtract, then phase difference, what I can say? Phase difference I can say that is a phi. Suppose phi I gave pi by 6. Then I can say the phase difference between these two waves is constant. Okay. So what is the coherent sources? Coherent sources are the sources which has the constant phase relation, okay, or constant phase difference. Maybe phase difference is 0, okay, or maybe whatever it is there, it has to be constant with time. It should not change with the time. So those sources are called coherent sources. Okay. So now what is the necessary condition for the coherent? Necessary condition for the coherent source? Frequency must be equal. Frequency must be equal. But because frequency will not be equal, then omega t term will not get cancelled out, and then the phase will depends upon the time. So phase will not be constant. So what is the necessary condition for the coherent sources? Frequency must be same. Frequency must be same. This everybody got or not? So coherent source, what is the coherent source? What is the requirement for the stable interference? Okay, everybody got? What is the necessary condition for the coherent sources? Everybody got? Okay. Now listen, next thing. Two independent sources. Okay, two independent sources. This example also given in NCERT. Two independent sources in even identical. Like you are buying the two Havells company bulb, same power, same manufacturing, everything is same. Okay, I am taking the example of suppose filament bulb. When we were using white light filament bulb, suppose everything is same company, same power, same, all the things are same. Okay, so identical, I am taking the identical source, but they are the independent, two different identical sources I am taking. So can we get the stable interference pattern? They are the coherent because they are identical, so they can be coherent? No. Why? Two identical bulb I am taking. Okay, in the bulb, who is the source? Basically, how I am getting the light from the LED, how I am getting the light in the filament bulb. So LED later in the semiconductor we will discuss. Like filament bulb, how we are getting the light. when electric current is passing through the filament is getting heated, means electrons or atoms are absorbing the energy. When they absorb the energy, electron will go to the excited state. Excited state is very short duration. Then what will happen? They will come back to the ground state by emitting the various photon. Okay. Everybody getting? Like this way, that photon will belongs to the visible region, so we will get the visible light. So bulbs are identical, everything is same. When we are passing, two bulbs I connected and then I pass the same electricity in both. Okay. Suppose in a one bulb, 500 electron goes to the third excited state. 500 electron goes to the third excited state and they are coming back to the ground state directly 3 to 1. And some electrons are in the fourth excited state, some electrons are the fifth excited state. In the same time, in the second bulb, same number of atoms will be in the same excited state. They will come back some together with a ground state. Is it possible? No. Overall energy will be equal because I have taken the same sources. So power is suppose 100 watts. So overall energy will be equal. We can say overall power will be equal. But in the both bulb, in the same time, same number of atom in the same excited state, they will come back to the same lower energy state simultaneously. It is not possible. So basically I am calling the bulb identical bulb, but in the bulb who is the source? Source is the what? Atoms, and all atoms will not be in the same state together or simultaneously. That's why we can say two independent bulb, two independent sources, even identical, they can never be coherent. They cannot be coherent. Everybody got or not? So if suppose they are asking in the assertion reason question, means two independent sources even identical, they cannot be coherent, then what is the reason? Because in the atomic level all the atoms will not be in the same excited state, all the atom will not emit the photon of same frequency simultaneously. That's why they will not be the coherent. Okay. So coherent sources, independent, and what is the necessary condition? Everybody got. So first, mathematically, I am going to the interference. We will derive the form. We will say the formula of the intensity. Then we will go to the YDSC. Okay. Completed. Okay. So now here, one thing I said in the class also. We are using in the alternating current also. We are using in the EM wave also. We are using in the SHM also. We are using in the wave also. When any quantity varies sinusoidally means it follow the sine function or cos function, like alternating current I is equal to I naught sine omega t, alternating voltage V is equal to V naught sine omega t, SHM X is equal to A sine omega t, wave Y is equal to X is equal to A sine kx minus omega t. All these are following sine function or cos function. That is called the sinusoidal. Okay. So in that case, peak value we can consider as a vector. Peak value we can take as a vector, and the phase difference between them we can take as an angle between vector. That is a phasor, maybe discussed in the class. That is called the phasor. So when any quantity follow the sine function, it varies according to the sine or cos, then that we can say sinusoidal variation. Sinusoidal variation. In that case, peak values of the quantity we can take as a vector, and phase difference between them we can take as an angle between vector. Okay, like here I write the two-wave equation. Y is equal to A1 sine kx minus omega t and A2 sine kx minus omega t plus phi. So here Y varies sinusoidally. Y follow the sine function in both cases. What is the peak value? That is called the amplitude. So peak value we can take as a vector. It means A1 and A2 I can take as a vector, and phase difference between them we can take as an angle between vector. So what is the phase difference between them? Phi. Okay, then what I can write, if I'm saying they are interfering or they are superposition. So what is the resultant amplitude? We can say resultant amplitude is what? A1 and A2, these are the two vector, and the angle between them is phi. What is the resultant formula in the vector? We have learned under root of A square A1 square plus A2 square plus 2A1 A2 cos phi. This everybody got or not? So peak value I took as a vector, and phase difference between them is the angle between vector. I think most of you know this formula. Completed. Up to this, okay? Okay. Now, suppose I am squaring on both sides, so I can write as what? AR square is equal to A1 square plus A2 square plus 2A1 A2 cos phi. Okay. Here frequency we are taking same. So we have learned in the wave intensity directly proportional to A square F square. Frequency of both waves are same. Then I can say what? Directly I directly proportional to A square. So A square is proportional to I, or I directly proportional to A square. Proportionality constant, suppose I am using C. Then this AR square I can write CIR. Okay. This A1 square I can write CI1. A2 square I can write CI2 plus 2 under root of CI1 into CI2 into cos phi. Okay. Now root C, that is a C get cancel out. What is the resultant intensity formula we got? IR is equal to I1 plus I2 plus 2 root I1 I2 cos phi. This is the resultant intensity formula. Why I have shown that derivation here? Why? Like you can think A square I can write as a I. A square I cannot write as a I. A square is directly proportional to I. But after both sides, when I put the proportionality constant get cancel out. That's why we are getting the formula. Otherwise, A square is not equal to I. Understood or not? Tell fast. Okay. So now these two formula we have to remember for the intensity, resultant intensity and the resultant amplitude. Some particular cases that we have to remember now. Cos phi, here we are getting the cos phi. What is the maximum value of sin theta or cos theta? That we know 1. Okay. So maximum value of cos theta or sin theta is the 1. Minimum value, if we are considering the sin also, so minimum value is -1. Okay. And average value of sin theta or cos theta is what? 0. That you have used in the alternating current also. That's why average value of alternating current in one cycle is 0. In one cycle is 0 because half cycle positive, half cycle negative. Okay. So maximum value of sin theta, cos theta 1. Minimum value, if we are getting the positive, negative both. So minimum value we will say -1. And average value is what? 0. That's why suppose I am saying in the interference, what is the average intensity? In the interference, what is the average intensity? So average I1 is constant, I2 is constant. Only average we will consider for cos phi. What is the average value of cos theta? 0. Average value of cos theta is what? 0. So this part will be 0. Then what is the average intensity in the interference? I1 plus I2. That is the sum of intensity of both. Somewhere intensity maximum, somewhere intensity minimum. But on an average when we are saying, then it is a total energy. Total energy is what? I1 plus I2. So average value of intensity in the interference is what? I1 plus I2. Are everybody got? Okay. Now we have learned the two interference, particularly one is the constructive interference, one is the destructive interference. What is a constructive interference? When intensity, they are meeting at the different points. If the intensity at any point is maximum, resultant intensity is maximum. Or another way we can say when it will be maximum, when the waves will meet in the same phase. So what is a constructive interference? Notes already you have. Okay, it is there maybe in the notes. What is a constructive interference? When the waves are at any point, waves are meeting in the same phase. Then intensity at that point will be maximum. It is called the constructive interference. So for constructive interference, what I can say? Constructive interference is what? When they will meet in the same phase. Okay. Waves will meet in the same phase. So same phase means what is the phase difference? Who will say? Same phase means what is the phase difference? Same phase means what is the phase difference? Tell fast. Same phase means what is the phase difference? Not only zero, because sine cos, you can think cos 0 1, then next complete one more cycle, one complete cycle, then again you come to the 0, basically it is a 2 pi, again complete one more cycle, 4 pi, then 6 pi, then 8 pi. It means even multiple of pi, cos theta will be 1. Okay, same phase means maximum intensity we will get. Okay, so phi is equal to 0, 2 pi, 4 pi, dot 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 2n pi. So when they will meet, that is called the same phase. When the phase difference is either 0, 2 pi, 4 pi, 6 pi, then we can say it is the same phase. Then cos phi will be equal to what? 1. Cos phi is the 1. Then I max, what I will get? I max is equal to under root of I1 plus root I2 whole square. And what is the A max I will get? A max is equal to A1 plus A2. Okay. How I got this root I1, root I2? You can see here 1. So this I can write root I1 square. This I can write root I2 square plus 2 root I1 I2. A square plus B square plus 2AB. That is A plus B whole square. Here, if I put in cos phi 1, then A1 square plus A2 square plus 2A1 A2. That is what? A1 plus A2. A1 plus A2 whole square. AR square is the A1 plus A2 whole square. Then what is the AR? AR is the A1 plus A2. So displacement, basically you can remember displacement we can directly add. When both are in the same phase, this plus this directly. So what is the maximum displacement? A1 plus A2. What is the maximum intensity? Root I1 plus root I2 whole square. Getting or not? These formula directly you have to remember. Okay. Similarly for destructive interference, what we can say? Destructive interference means opposite phase. Waves will meet in opposite phase. Opposite phase, then intensity minimum. Okay. Opposite phase means what? Phi has to be pi, 3 pi, 5 pi, means odd multiple of pi. Then what is the cos phi we will get? Cos phi will be equal to -1. When it is a -1, then intensity will be minimum. What is the I min? I min we will get what? Root I1 minus root I2 whole square. Okay. What is the A min I will get? A min is equal to A1 minus A2. Mod we can write, which one is more, from that you will subtract. Okay. Up to this, okay. Suppose they given the amplitude and they are asking what is the ratio of the maximum to the minimum intensity. They given the A1, A2 amplitude or amplitude ratio they given, and they are asking ratio of maximum and minimum intensity. So I max upon I min, what I can write? That is equal to what? A1 plus A2 whole square upon A1 minus A2 whole square. They give an amplitude ratio and they are asking the maximum and minimum intensity ratio. Then we can use like I is equal to I max is the what? I directly proportional to A square. So I max is equal to proportionality. When I will take the ratio, proportionality constant will get cancel out. Okay. Completed. One last formula for the interference first here. If I am saying if I1 is equal to I2 is equal to I, intensities of both I gave equal, okay, then what is the resultant intensity formula we can use? We can use that also, I plus 2 root I into cos phi. That also we can use, but from this we can use another formula we have to remember. If I all are equal, then I resultant what I will get? I plus 2 root I means I cos phi. If you are taking the 2I common, then finally that you have to remember 4I cos square phi by 2. This formula we can only use when the intensities of both interfering waves are equal. Otherwise, we will go to the basic formula I1 plus I2 plus 2 root I1 I2, and I max we will use root I1 plus root I2 whole square. But when the intensities of the both wave they given equal, then we can directly use this formula. From that I max, what I can say, I max is equal to 4I, and I min, what I can say, I min is equal to 0. I min is equal to 0. Why? Root I1 plus root I plus root I. Root I plus root I, 2 root I. Whole square, 4I. So maximum intensity, what we got? 4I. And root I minus root I whole square, what we got? 0. So when intensities of both waves are equal, suppose it is a I, then maximum intensity will be 4I, minimum intensity will be 0. If they are not equal, then I max is the root I1 plus root I2 whole square, and I min is the root I1 minus root I2 whole square. Everybody got? Okay. And last one relation we have learned in the wave, relation between path difference and phase difference. Path difference and phase difference. So then delta phi is equal to 2 pi by lambda into delta x. This formula is very important for the YDSE. We are using most of the places we are using this formula. Delta phi is equal to 2 pi by lambda into delta x, or k delta x we can say. So relation between path difference and phase difference, delta x is the path difference, delta phi is the phase difference. Why this formula is we are using here? What is the use of this formula? Anybody will say? Like suppose I am saying, I am considering the two sources S1 and S2. They are the coherent sources. They are meeting at any point on the screen at the different point. Okay. Now suppose the waves are going and it is meeting at any point P. Now you can see here. Maybe suppose I am saying initially the wave phase difference is what? 0. Initially the waves are at the same phase. Initially they are in the, both sources are in the same phase. Both S1 and S2. So initially they don't have the phase difference. Okay. But when they are meeting at any point P, now from the figure you can see S1 wave, the wave from the S1, it is traveling lesser distance, and S2 wave are traveling more distance. Everybody getting or not? S1 wave is traveling lesser distance and S2 wave is traveling more distance. Okay. It means initially they are at the same phase, but due to the different path length, S2 wave is traveling more path to reach at P, S1 is traveling less path to reach to the P. Suppose any point is below, then S2 will travel lesser, S1 will travel more. Now what will happen? Suppose its path is x1, its path is x2. Then what is the path difference? Delta x, I can say x2 minus x1. For this point P, path difference for the wave I can say x2 minus x1. Now path difference is delta x. So due to the path difference, phase difference will come. How much phase difference will come? Delta phi is equal to 2 pi by lambda into delta x. So maybe in the whole YDSE, whole interference experiment, we are taking initial phase difference between the S1 and S2 is 0. But when they are meeting at the different point on the screen, due to the path difference, phase difference is coming. Okay, so maybe S1 and S2 waves does not have the initial phase difference, but due to this path difference, phase difference is coming. Everybody got or not? So that's why this formula is important. Somewhere they are meeting, they are traveling the equal distance, like bisector. Suppose here S1O and S2O are equal. When it is a equal, then path difference is 0, then phase difference will be 0. So like that way, different point, due to the different path difference, what will happen? Phase difference will come. Phase difference will come, so intensity will be different at the different point. Okay, so that's it, the what? Interference. We are observing when the waves are meeting, two waves are meeting, waves are coherent, but on the screen what we will observe? Here intensity more, here intensity less, more less, like this pattern we will observe on the screen. Okay, so that is the stable interference pattern we can say, because we can recognize here I'm getting more brighter, here I'm getting dark, here I'm getting bright, here I'm getting dark. So that is a stable interference pattern. Everybody got? Okay, so first few questions we will discuss in this I1, I2 formula, then I will come to the YDSC. Okay. Two waves of, suppose I am taking simple question, two waves of equal intensity I of each wave meet at any point. Okay, then maximum intensity, that is a two coherent, I have to mention here. Intensity is I1. And if sources are incoherent, then at that point intensity is I2. What is the ratio of I1 by I2? Very simple question. Okay. Tell fast. Two coherent waves are there. They are meeting at any point, and maximum intensity we are getting what? I1. And when the sources are incoherent, then intensity we are getting I2. Then I'm asking what is the ratio I1 by I2? Then I1 by I2 we have to find. Now listen, because we have to know that in the incoherent sources what will happen. When the sources are coherent, maximum means what? If I'm taking equal intensity I and I, so then maximum intensity what I got? 4I. Okay, so it means I1 I can say what? I1 I can say 4I. Okay, and when they are incoherent, then what will happen? At any point continuously, like phase are, because the sources are incoherent, so continuously intensities are changing. So throughout the screen we will see the equal intensity. Like in your room where you are sitting, so many bulbs are there, but on the wall all the bulbs light rays are meeting, but on the wall you cannot identify where is the maxima, where is the minima. On the whole wall you will see the equal intensity everywhere. Why you are not observing the maximum minimum? Because these bulbs, independent bulbs, are incoherent. That's why incoherent, then what will happen? Everywhere we will get the intensities equal. And energy is the scalar quantities and average energy and all the points what I can say. I1 plus I2. So here both are equal, then I can say 2I. So coherent case 4I, and incoherent case everywhere on the point. There will be, I will not call same phase, opposite phase. Why? In coherent sources, phase is continuously changing. So I will not say maximum minima. Throughout the screen, intensity will be equal. That will be what? I1 plus I2. Now from this I1 upon I2 ratio, what I got? 4I is to 2I. That is what? 2 is to 1. Okay. Now you will say, suppose I am saying, I am considering the two coherent wave of equal intensity. A small theoretical question first I am discussing. Two coherent wave of equal intensity. Two coherent wave of equal intensity. At any point they are meeting in the same phase. At any point they are meeting in the same phase. They have equal intensity. At any point they are meeting in the same phase. So we are getting same phase means we are getting the intensity there is I0. Two coherent wave of equal intensity. They are meeting in the same phase at any point, and the maximum intensity at that point I am getting I0. Intensity at that point I am getting I0. Now I cover one source. What is the intensity at that point? When I am taking equal intensity, then when they are meeting at any point where they are meeting in the same phase, intensity is I0. Now I cover one source. What is the intensity at that point? What is the intensity at that point when I cover one source? One by four. Very good. Why? Because now when I cover one source, then only one source is there. due to the one source, no interference, no distribution of energy, then what will happen? Everywhere intensity, no maxima, no minima, because for the interference we require the two or more than two wave. Now here, one source covered means one wave removed. Now only one wave is there, so everywhere intensity will be due to the one wave. And maxima, when equal intensities are there, then we know that what? I max is equal to 4I. That I gave what? I naught. So what is the intensity of each wave? I naught by 4. I naught by 4. Now when I remove one source, only one source is there. Due to that source, intensity will be equal everywhere. Then what is the intensity? I naught by 4. Everybody got? Completed? Okay, next problem. So coherent, everybody got. Incoherent, everybody got. Incoherent case, everywhere the intensity will be equal because the distribution of energy will not take place. Okay. Second thing, in the interference, suppose I am saying two waves, I am taking S1 and S2, two sources. They are meeting in the same phase, any point. Suppose their intensities I am taking I and I. So here what we are getting? 4I. Okay. So how much energy is meeting at the point P? How many waves are meeting at this point P? How many waves are meeting at the point P? Two waves. One is coming from S1, one is coming from S2. So how many waves are meeting at the P? Two waves. Each wave, suppose energy I am taking I and I. Each wave energy is the I and I. So energy is a scalar or vector? Energy is a scalar or vector? Energy is a scalar quantity. Okay. So how many waves are meeting at the P? I and I. I and I. Then if I'm going to the energy addition, so I and I is meeting, then how much energy I should get at P? If I'm saying two waves of equal intensity I and I, they are meeting in the same phase at the point P. So how much energy are meeting at the P? We can say I and I, that is a 2I. But how much energy we are getting at P? How much energy we are getting at P? If they are meeting in the same phase according to the interference, if they are meeting in the same phase, what is the intensity at P? 4I. But how much energy are meeting at P? 2I. Okay, it means 2I I am getting extra. Energy violation will not be there. So I and I are meeting. So energy scalar, it should be the 2I. But how much we are getting? 4I. It means extra energy produced in the interference? No. What will happen? Now anywhere they are meeting, suppose that point is the Q. They are meeting in opposite phase. When they are meeting in opposite phase, then how much energy are meeting at Q? How much energy are meeting at Q? How many waves are meeting at Q? I and I, two waves means I and I. How much energy are meeting at Q? I can say 2I. But what is the energy at Q? What is the energy at Q? What is the energy at Q? 0. Why? Opposite phase means minima. Minima means intensity is equal to 0. Now if you see the total, I, how much energy are coming? I am considering here 4I. How much energy is the output? 4I plus 0. That is equal to what? 4I. It means no extra energy produced, no energy violate. Only what is happening in the interference. In the interference, it does not violate the energy conservation. Only what happened, there is a redistribution of energy. There is a redistribution of energy. Energy which will disappear at minima. Energy which will disappear at minima. Because here I and I are meeting. But what is the energy at minima? I am getting darkness, complete darkness. Means light meet at Q. Two lights meet at Q. But what is the light at the Q? No light is there. Means darkness is there. Where that energy gone? That energy gone to the maxima. That's why maxima become more brighter. Maxima become more brighter and minima is the completely dark. So energy which will disappear at minima, it will appear at maxima, but overall energy, total energy will be constant. Total energy will be constant. This everybody got or not? So in the interference redistribution of energy take place, energy which will disappear at minima, it will appear at the maxima. So maxima intensity will be more and the minima intensity will be 0. Otherwise, if they are unequal, then root I1 plus root I2 whole square upon root I1 minus root I2 whole square. Everybody got or not? But overall total energy will be constant. If these sources are incoherent, then here I and I are meeting, here I will get 2I. Here I and I are meeting, here what I will get 2I. No redistribution will take place. Everywhere intensity will be 2I when we are taking the sources are incoherent. So that's why to identify the maxima minima, we have to take the sources what? Coherent. Then only we can get the stable interference. Here maxima, here minima, here maxima, here minima. Understood? Completed. One more thing. Suppose here each sources energy I am taking I and I. Okay, so basically here what is energy? I. Here energy is what? I. So that is about 2I. Total energy I am taking 2I, but suppose I am taking this is the I by 2 and suppose this I took the 3I by 2. Okay, total energy is the 2I, but one energy, the energies of the both sources are, both waves are different. One is the I by 2, other is the 3I by 2. What is the effect? What is the effect on the intensity at maxima and minima when the sources have the different intensity? Okay, again I am repeating. I am comparing with respect to the equal intensity. Initially they have equal intensity I and I. Maxima I got 4I, minima I got 0. This similar question has given in module also. Now I am taking what? Intensities are different, but the total energy I am taking suppose constant. Total energy is what? 2I, but one has the energy I by 2, other has the energy 3I by 2. Now what is the effect on the intensity at maxima and minima? What is the effect on the intensity at maxima and minima? Maxima decrease. Now when they will be different, then what will happen? We will take the maxima is what? Root I1 plus root I2 whole square. Minima we will take root I1 minus root I2 whole square. Now both are not equal, then minima will not be completely dark. Minima will not be completely dark. Why? Minima intensity will be root 3I by 2 minus root I by 2 whole square. That is the energy of minima. And maxima I will get root 3I by 2 plus root I by 2 whole square. Now earlier whole energy of minima was going to the maxima. That's why maxima was 4I, minima was 0. Minima was completely dark, maxima was the more brighter. But now what is happening? Whole energy of minima is not going to maxima because minima is also taking some energy. How much? Root 3I by 2 minus root I by 2 whole square. It means whole energy of minima does not go to the maxima. So maxima brightness decrease. And minima, it is not 0. It has some intensity, means minima brightness increase. Minima brightness increase. Everybody got? Okay, so when they are changing the intensity of the sources, but the total energy we are taking constant. We are comparing with respect to the initial. Total energy we are taking constant, but energies of the sources are different. Intensity of both sources are different. Then we can say maxima will not be minima will not be completely dark. So minima will have some intensity. That's why to see the stable and clear interference pattern, we are preferring equal intensity. We are preferring equal intensity. Why? In the case of equal intensity, we can recognize easily darkness, brightness, darkness, brightness. But when the intensities are not equal, then minima will not be completely dark. So it is just difficult to recognize where is the maxima, where is the minima. So to get the clear interference pattern, to observe easily, identify easily, we are taking the sources of equal intensity. One last question of interference, then I will come to the YDSE. This question, maybe this type of question is important also. I max upon I min upon I max plus I min. Tell fast. If suppose ratio of the intensity of the two wave I gave C, then I'm asking what is the ratio of the I max minus I min upon I max plus I min. Wow, very fast. Answer you mugged up. Okay, so I max intensities are different, so I will not take I max is the 4I, I mean I will take 0. So what is I max? I will take root I1 plus root I2 whole square, I mean root I1 minus root I2 whole square. Or I can say I1 plus I2 plus 2 root I1 I2, I1 plus I2 minus 2 root I1 I2. Now you can see I1 I2 will get cancelled out. Numerator what will remain? 4 root I1 I2. 2 root I1 I2, 2 root I1 I2 will get added. And the denominator I max is what? I1 plus I2 plus 2 root I1 I2. I min is what? I1 plus I2 minus 2 root I1 I2. In the case of denominator, 2 root I1 I2 will get cancelled out. So what I will get? 2 into I1 plus I2. If you can remember, directly remember this result. Now this 4 and this 2. Now I know the ratio. I know the I1 by I2. So I will make I1 by I2. How? Divide with I2 in the numerator and denominator. Who is playing with the screen? We will divide I2 in the numerator and denominator. So 2, I have the root I1 I2. If I divide with I2, I divide with I2. Inside the root, it will become I2 square. Upon denominator when I divide, so I1 by I2 plus I2 by I2. So in numerator and denominator, I divide with I2. So no change in the fraction because I did in the numerator as well as denominator. Now here 1 I2 get cancelled out. What is the I1 by I2? Is the C. So that is equal to what? 2 root C upon I1 by I2 C plus 1. Then there is the intensity. Okay. Completed. Now Young's double slit experiment. Other question of the interference I will discuss in YDSE. Okay. What was the Young double slit experiment? What Young has demonstrated by his experiment? What Young demonstrated? So listen. By his experiment, he demonstrated the interference of the light. Interference of light. By his experiment, he has shown or he demonstrated interference of light. So by his experiment, he shows that he took the two coherent waves, and on the screen he has shown maxima, minima, redistribution of energy, somewhere brightness, somewhere darkness, like that he has shown in the screen. So then he demonstrated interference of light. So Young's demonstrated interference of light. Okay, these things also, theoretical thing also we have to know. Like what I said, suppose they ask who verified the wave nature of light? Who verify? Huygens. Who verify the interference of light? Young's. Okay. Who verify the particle nature of the radiation, photoelectric effect? Who gave the concept of the wave nature of the particle? Who gave wave nature of a particle? Who gave the concept of the wave nature of a particle? A little fast. Wave nature of a particle. Wave nature of a particle, de Broglie hypothesis. De Broglie said, now all the moving particle we can associate a wave. Like these things, theoretical things we have to know. Okay, maybe they can ask the theoretical question. So Young has demonstrated interference of light. Up to this, okay? Okay. So he want coherent sources. Okay. And we know that even we are taking the two identical sources, they will not be the coherent. Two identical sources when we are taking, then also they will not be coherent. Then there was a problem to find the coherent sources. Then what he did, he took only one source, that was the primary source. Okay. Now suppose I'm taking one light source, and in the path of the light source I'm putting one opaque screen. Okay, opaque object I'm putting like this. Okay. Now I put the opaque screen in the front of the source. Now take the needle or blade. Okay, but just make the two hole at the one point, suppose here, and one point here. So by the needle, make the two holes. Okay. Now when you will make the hole in that screen, then what will happen? From the hole, light can pass. From the hole, light can pass. I took the two holes, means two holes light can pass. According to the Huygens principle, when the wave travel in the medium, all medium particle behave like a source. All medium particle behave like a source. Okay. So here S1 and S2, there is a hole, so light will pass through the hole. Okay. Now S1, S2 will behave like a source. Okay. So they are the two sources. One thing, they make from the one source only. They make from the one source only. So whatever the change, that is the one paragraph has given in the NCERT for this only. There will whatever the change will be there in the SS, the same change will be in the S1 and S2 together. Suppose in the S, 10 atoms are in this excited state, 20 are in this. So whatever will happen with the S, same will happen with the S1 and S2. Then I can say what? S1, S2 they make from the single source. So now S1 and S2 are the coherent because they will have the constant phase relation. Okay. So now from the one source, because the two independent sources cannot be coherent. So that's why he took the one source. From the one source, he make the two coherent sources. Everybody got or not? Now he took the screen, and the distance between the screen and we are taking the hole basically. Slit means what? Take the blade, by the blade, cut like this, then that is called the slit. This is the slit. Okay, in the screen, if you puncture the screen by the needle, so that is a hole, means point source. If you are taking the blade and cutting the screen like this, so that is called the slit. But in the whole chapter we are dealing with the hole. Pinhole means we are considering the source are point source, and point source we are considering the wavefront is what? Spherical. So we are calling it is a Young's double slit experiment, but numerically we are everywhere considering what? Pinholes. Okay. This everybody got? Distance between these two sources, suppose I am taking small d. This is the condition, that's a necessary condition to get the clear interference pattern on the screen. Capital D is greater than small d. That has a required condition. Who will say why? Why capital D should be very large in comparison to small d? Why capital D should be very large in comparison to small d? Reason is what? Suppose this screen I am taking very close. This screen if I am taking very close to the source. So then what will happen? When the waves will travel from S1 to S2. So what will happen at here, if I am considering the points are and it is a very close, then some waves what will happen, the path difference will be what? Negligible. Like suppose I am saying maxima, minima on the screen we want to get. But the maxima minima distance will be very, very small, or consecutive maxima distance will be very small. Consecutive maxima, like maybe fringe width formula you marked up, capital D lambda by small d. In that capital D is very small, so fringe width will very small. Fringe width means consecutive maxima, distance between consecutive maxima or consecutive minima. If that distance is very small, then what will happen? They will start overlapping. So we cannot identify where maxima, where minima. So when capital D is very small or capital D is not very large in comparison to small d, so then maxima, minima start overlapping. Maxima, minima will start overlapping. Then we cannot identify here maxima, then minima, here maxima, then minima. Why? Some maxima start overlapping. Okay. So that's why to see the clear interference pattern on the screen, capital D should be very large, so that easily we can identify this is the maxima, then minima, then maxima, then minima. So this is the necessary condition to observe the clear interference pattern on the screen. Capital D should be very large in comparison to small d. That is the one reason. Second reason, we consider to find the path difference and all, we consider the parallel wavefront, parallel waves from the slit S1 and S2. When they are meeting at any point, we are considering the parallel waves. For the parallel waves, we have to take the capital D must be large in comparison to the small d. So these are the reason that condition is required. Capital D should be very large in comparison to small d. Otherwise, maxima and minima will start. Some maximas start overlapping. We cannot identify the clear pattern on the screen.